Quadratic equations are equations like these, in which the highest exponent of x is 2. There are several methods we can use to find the locations of these crosses, or the roots. And in this video, we shall focus on solving quadratic equations using a technique called factorization. Let's say we have this equation and we want to solve it. The coefficient of x squared is 1. To factorize the equation, we need to find a pair of numbers a and b, whose product is equal to the red part of the equation, -15. Their sum must also be equal to the orange part of the equation, +2. In this table, we will try different pairs of numbers in the left column, whose product is -15. We will then check their sums in the right column. We're looking for a sum of 2. 1 and -15 add up to -14, not 2, so that's not the correct pair. 3 and -5 add up to -2, so that's not the correct pair either. Next, we have 5 and -3. Notice that we began with the smallest positive factor, 1, and increased it systematically. This time, 5 and -3 indeed add up to 2. Therefore, this is the pair of factors that we were looking for. We can now write the quadratic equation in this factorized form, because +5 and -3 are the pair of factors that work. This product equals 0. That can happen if either the blue factor or the orange factor is 0. Solving the two equations separately gives us x equals -5 and x equals 3. These are our answers. Now, let's try another example with a different equation. As before, the product of the two numbers must equal the red part, 12. Their sum must equal the orange part, 7. Let's explore the factor pairs of 12 in the left column and check whether any of them add up to 7. We have found a pair already, 3 and 4. They add up to 7. We can therefore write the factorized equation. Either the blue factor or the orange factor can equal 0. Solving these two equations gives us the results -3 and -4. In this next example, the coefficient of x squared is 8, rather than 1. And because of this, we first multiply the blue part by the red part, giving us -120. -120 is therefore the required product of a and b. Their sum is still the orange part, 2, just like before. Let's now explore the factor pairs of -120. So far, none of these pairs add up to 2. We can also move the negative sign from one number in each pair to the other. The products will still be -120. However, none of these pairs adds up to 2 either. Up to this point, we have only tried positive factors from 1 to 4. Let's continue with some larger factors. 5, then 6, then 8, and finally 10. We still haven't found a pair that adds up to 2. Once again, we can switch the negative sign between the two numbers in each pair. Now we finally have a pair of numbers that add up to 2. This time, however, we cannot write the factorized form directly because the coefficient of x squared is 8 Instead, we split the orange 2x into positive 12x and negative 10x. The coefficients 12 and negative 10 are the two numbers we found, and the resulting terms add up to 2x. We assign green to the first two terms and purple to the final two terms. Next, we factor out the greatest common factor from both the green part and the purple part. Instead of saying greatest common factor every time, we will simply use the abbreviation GCF from now on. The GCF of the green part is 4x. Multiplying 4x by 2x gives us 8x squared, while multiplying 4x by 3 gives us 12x. For the purple part, the GCF is minus 5. Multiplying minus 5 by 2x gives us minus 10x. And multiplying negative 5 by 3 gives us negative 15. In the next equation, we combine the green factor 4x and the purple factor minus 5. In other words, this factor is formed from the two GCFs. The second bracketed factor is 2x plus 3, which appeared in both the green and the purple parts of the previous equation. This product can equal 0 in two different circumstances. Solving the two equations gives us the green and purple solutions to the quadratic equation. Let's move on to the next example. In this case, the product AB is 18, while the required sum is the orange 11. We will now try some factor pairs of 18. And that was quick. We have already found the correct pair, which adds up to 11. As in the previous example, we split the orange 11x into positive 9x and positive 2x. Then assign green and purple to the two groups of terms. We factor out the GCF from each group. This gives us the factorized form of the equation. Either the green or the purple factor can equal 0. The two resulting fractions are our answers. Now, let's consider another example. Here, the product of the blue and red numbers is negative 72. Therefore, negative 72 is the required product of A and B. The coefficient of x is the orange 1, so the required sum of A and B is 1. Let's test different factor pairs of negative 72 and see whether any pair adds up to 1. No luck so far. We can switch the negative sign between the numbers in each pair, but none of those combinations works either. We have only tested positive factors up to 4 so far, so let's continue from 5. Next comes 6 and 8, but we still have no luck. After switching the signs again, we finally find the correct factor pair, adding up to 1. We now split the orange x term into minus 8x plus 9x. The two groups are then colored green and purple. From each group, we factor out the greatest common factor. We can now write the equation in factorized form. Either the green factor or the purple factor can equal 0. Solving them gives us two fractional answers. Now, consider this equation, which has no x term. Its coefficient is therefore 0. The product we need is the red negative 36. and the required sum is 0. For two numbers to add up to 0, they must be opposites of each other. Which two numbers have the same magnitude and multiply to negative 36? They must be 6 and negative 6, right? So there's no need to test any other factor pairs in this case. We can write the factorized form directly. Either the blue factor or the orange factor can equal 0. Therefore, x can be positive or negative 6. These are the two square roots of 36. So in this particular example, we could have just reached the same answers by simply taking the positive and negative square root of 36. Let's move on to another example in which the coefficient of x squared is not 1. The required product is negative 36. And the sum is 0 because the quadratic equation has no x term. Once again, the required numbers are 6 and minus 6. However, this time we cannot write the factorized equation in a single step. We rewrite 0x as positive 6x minus 6x. Next, we factor out their GCFs, and after simplifying, we obtain the factorized form. Either the green factor or the purple factor can be 0. The answers are positive 3 halves and negative 3 halves. Finally, let's examine an example with no constant red term. In other words, the red part is 0. In this case, we don't need to use a table at all. We can simply factor out the greatest common factor of the expression. Either 2x or x plus 4 must equal 0. This means that x is either 0 or minus 4. We have now mastered solving quadratics by factorization. Please consider liking, commenting, and subscribing to support the effort that goes into making these videos. There are also other methods for solving quadratic equations, such as completing the square, which we will explore in the next video. It should be on your screen right now, so be sure to check it out next.